G'day all, welcome to another assembly tutorial. Today we're looking at some really interesting instructions. These are called the inserting and extracting instructions, and most of them are from SSE 4.1. So if you've got an older Intel or an older AMD, you mightn't be able to do a lot of these, but you'll still probably have the insert and extract words instruction. Anyway, these are basically about inserting a particular element into an SSE register or extracting one particular element from an SSE register. And you can insert things from, you can insert an element from an x86 register into an SSE register, and you can extract one of the elements from an SSE register and store it into an x86 register. So they're pretty cool, really. And here they are. So we've got a lot to go through, but they're all pretty simple except for this first one. This is no particular order, I just kind of picked this out randomly, but yeah, basically we've got, what's that, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 instructions to look at. Okay, so insert packed singles. This one copies a selected single from the source to the destination. The 8-bit immediate operand is used to select the single. Yeah, so all that we're doing here is copying one of the elements from the second operand into the first operand. But you've also got the option of zeroing certain elements in the destination, this first operand here, if you want. This is an SSE 4 instruction. And if the second operand is mem32, a scalar real 4 in memory, then the source specification is what? Oh yeah, if your source operand isn't an SSE register, then yeah, it's just assumed to be 0. You know, the 0th element of a scalar mem32 single. Anyway, this is the way that the 8-bit immediate operand works. So it's broken up into bits. We can see just here the first 4 bits. So this is bit 0 right over here on the right hand side, or the least significant bit if you like. The first 4 bits are the 0 mask. The next 2 bits specify a little 2-bit number. That's the number from 0 to 3. And that's the destination index. And the next 2 bits specify the source index. So yeah, we select one of the singles from the source. That's the second operand. And we store it at the position specified by the destination. And that's going to go into the first operand, and we can also zero some things. Okay, that's good. Let's have a look at how it works. Alrighty, insert packed singles XMMO, XMM1 with that bit pattern. Okay, so I've drawn out that bit pattern a little bit larger, sort of underneath a magnifying glass just here. Basically what we've got is a 0 mask of 1010. The destination index is 3, or 11 in binary. And the source index is 1. So this is what's going to happen. The very first thing that happens is that the 0 mask is applied. So XMMO is our destination, and each element in XMMO that corresponds to one of these 1s in the 0 mask is going to be changed to 0. So it's just an additional little flexibility that this instruction has. And the next thing that happens is that the source index element, which is 1, and at the moment in XMM1 that has a 1.2. That's going to be copied to the element specified by the destination index, which is 3. So in the end, we're just going to copy that, element number 1 into XMMO right there, and we're going to zero a few more. So that's insert packed singles. Whoa. I wasn't expecting that. Okay, extracting packed singles. Things get a lot easier from here on in. That's a tricky instruction, but yeah, they're a lot easier after that. So the opposite to inserting a packed single is extracting a packed single, and this takes 3 operands as well. The first one can be a 32-bit register or memory operand. The second is an SSE register, and the third is an immediate 8 value. Once again, this is an SSE 4.1 instruction, so you mightn't have this on older AMD chips. Alright, so this is really simple actually. The element number specified by the immediate 8 operand gets copied from the second operand into that x86 register that you specify as the first operand. Yeah, so extract PS, EAX, XMMO, and 2 is going to do exactly that. It's going to copy 54.8 into EAX. And I've actually drawn 54.8 out as a number, you know, because EAX isn't a floating point register. But yeah, that bit pattern just there for 54.8 is going to be copied into EAX. That is to say that it's not going to be casted or anything like that. Okay, good stuff. Now packed, insert, byte. Yeah, all of the rest of these are fairly similar, so we can just rush through them really quick. They're really useful instructions though. This instruction grabs a single byte from the second operand and puts it into the first operand at the byte index specified by the immediate 8 operand. Yeah, if the second operand is a register 32 or a 32-bit register, only the lowest byte, AL, BL, CL, R8, B, etc. is moved. Yeah, so if you've got a value in an x86 byte register and you want to place it at some byte in an SSE register, this is the instruction for you. It works exactly as you'd expect. You just use the immediate 8 value to specify the index where you want the byte to go. So here I'm using EAX, but actually only AL is going to be read. So PINSRW or PINSRW byte with those two operands is going to put the 14 at byte index number 12, just like that. Okay, likewise we've got extracting bytes. This is pretty similar as well, only this time the 12th byte will be copied from the SSE register and placed into AL. Yeah, so I've used EAX again, but it's AL that will get the actual value. So the 12th operand of XMMO is actually 4. I'm not sure where I got 14 from. Oh. Yeah, okay, yep. So AL did have 14, I guess. I was trying to indicate there, but now it's got 4. After the instruction, it's going to have 4. Yeah, we've just copied the 12th byte. Okay, likewise, we can insert a double or a Dword. Yeah, I should say Dword instead of double, just to save confusion. These are not floating point values, these are integer values. So an integer Dword, pretty much exactly the same as inserting a byte. You just use the immediate 8 operand to specify yeah, whereabouts in the SSE register you want to copy your Dword to. Yeah, so something like this. This is going to copy the value of EAX into the Dword element number 1 in XMMO. Simple as that, really. Extracting a Dword is just as simple. Yeah, just use the immediate 8-bit operand to specify which of the Dwords you want to extract. And then that can go into one of the x86 registers. So I've got 0 just here, that's going to copy the 9, or element number 0, from XMMO into EAX. Beautiful, look at that. It did exactly what I said. Yeah, I could have drawn these slides to do anything, but no, that's really what it does. Anyway, insert a Qword as well. So this is pretty basic as well. PINSRW, XMMO, RAX, and 1 is going to grab 83 from RAX, the Qword version of the RAX register, and it's going to store it in the Qword number 1 of XMMO, which is the top Qword, or the top half. There we go, just like that. Of course, we've got extracting Qwords as well, and that works in almost exactly the same way as the previous extracting instructions. This one's going to grab 54 from XMMO and store it in RAX. Look at that. There we go. Okay, inserting and extracting words. Yeah, so the good news about this particular instruction, or some of these anyway, is that some of them are from SSE 2. So all of the previous instructions that we've looked at were actually from SSE 4.1, but some of these are from SSE 2, so that's quite cool. They work basically the same. something like this: p insert word xmmo eax and 1, when eax has that and xmmo has that, is going to do that. Yeah, so I actually used eax, which is obviously the Dword version of rax, but it's only going to read the word. Yeah, the top bit is, it's just going to ignore it. So this is basically just going to copy a 9 into the first word of xmmo. How good is that? Okay, finally, I think this is the last one. Extracting a word. Yeah, this is going to extract word number 6, or the word at element number 6 of xmmo. Granted that xmmo is apparently holding words. It's going to extract that 6th word and store it in rcx. Yeah, so that's a 3 just there, I think. What's that? 0, 1, 2, 3, 4, 5, 6. Yeah, it's a 3 just there. So the other important thing to note is that, like a lot of these instructions, when you change the lower end of, some of the 64-bit instructions, there's an implicit 0 extend that happens. So the top of RCX right here is actually going to be, the 3 will be 0 extended to 64 bits. It's pretty good to know that, really. Pretty good to know. Happens all the time. Lots and lots of instructions. Anyway, that's extracting and inserting words, Qwords, Dwords, pretty much whatever sized words you want to insert and extract. Really useful instructions, folks, and thank you very much for listening. See you later.